Hello, welcome again. Today we're going to look at section 8.2 in our geometry text, the Pythagorean Theorem and its converse. Pythagorean Theorem, something that we may be familiar with from past mathematical conversations, states if a triangle, we'll call this triangle ABC, is a right triangle with sides A, B, and C, then A squared plus B squared equals C squared. So again, this is the Pythagorean theorem. If we have a right triangle with three given sides, then the two legs, which are BC and AC, squared, the sum of that will equal the hypotenuse, or C squared. Another definition: a Pythagorean triple is a set of three positive integers, A, B, and C, such that the Pythagorean theorem holds true. So an example of Pythagorean theorem is 3, 4, and 5. They are three positive integers, so they have to be positive numbers, that hold the Pythagorean theorem true. We can show that then by saying that 3 squared plus 4 squared does in fact equal 5 squared. So if you're asked to find or solve for Pythagorean triples, or ask if you do have Pythagorean triples, put it through the Pythagorean theorem, and if it's true, they are triples. If it's false, they're not. Question using the Pythagorean theorem says find the hypotenuse. That is the value of x. We'll take the two legs without really worrying about which one's A or B. We'll just say that 5 is A and 12 is B. We have the Pythagorean theorem. Plug in the information. 5 squared then plus 12 squared is equal to x squared. 25 plus 144 equals x squared. We will square root both sides after we've added them together, and we'll have x is equal to 13. Again, it is positive or plus or minus 13, but we'll deal with the positive values here. So solving for x, that's one thing that we're pretty accustomed to. One thing that is a little more difficult, or not as used to, is solving when the value is not the hypotenuse. So here we have 7, and then x as the two sides, and 14 as the hypotenuse. The hypotenuse is always the C. So when we plug in our values to solve, we need to be careful and make sure that we have our variable on the left side of the equation. So it's not always that the variable goes on the right side. Here we have the variable on the left. We have 7 squared plus x squared equals 14 squared, and then we solve accordingly. 7 squared is 49. And 14 squared is 186. Subtract 49 on both sides. We're left with x squared is equal to 147. Square rooting that, and simplifying, we're left with 7 square root of 3 as our value for x. So again, please don't get in the habit of always just putting the variable on the farthest right side of the equation. Alright, finding the area of a triangle. If we have an isosceles triangle, which we do, two sides 7 and 7 being the same, we know that the altitude that is dropped from the top is actually a perpendicular bisector, which means that the two sides of two different right triangles are 5. So if we're trying to find the area of a triangle, we need to have the area formula, and the area formula of a triangle is 1/2 the base times the height. We know the base is 10, and we're trying to solve for the height. So again, there's the formula for area of a triangle. The information that we're going to use then will be with the Pythagorean theorem. 5 squared plus h squared equals 7 squared. 25 plus h squared is equal to 49. And then solving, h squared is equal to 24, square root of that, and we're left with 2 square root of 6 as the height. With the formula, if we know the base is 10 and the height we just solve for as 2 square root of 6, we can plug those in. We have area is equal to 1/2 the base 10 times 2 square root of 6, simplifying then with our exact value as 10 square root of 6, or approximately 24.5. So again, applying the idea of Pythagorean theorem to a triangle, solving for the height, and then finding the area of the triangle by using the height that you solve for. This is a question that will end up on the test. Alright, indirect measurement. Two antennas are supported by cables 100 feet long in length that are attached to the same point on the ground. If the cables are attached to antennas 50 feet above the ground, how far apart are the antennas? Take a look at a diagram here. So we have two 100-foot cables are attached to the same point on the ground. So here's the point on the ground. The cables are 100 feet in length. The poles they are attached to are 50 feet in length. I want to know what the distance is between the two of them. So if you kind of look here, we have two right triangles that are formed. We want to know what this entire length on the bottom is. Without much thought, I'm sure we're going to use the Pythagorean Theorem. And here is the work that it ensues. If we have one of the sides 50 and we call the base x and they're both x's, then we have 50 squared plus x squared equals 100 squared. So then simplifying, we have 2500 plus x squared equals 10,000. We subtract and we're left with x squared is equal to 7500. X is equal to the square root of 7500, and then we're left with 50 square root of 3. So that is the value for one base for the distance between. We have two of them, so therefore we'll add them together. 50 square root of 3 plus 50 square root of 3 equals 100 square root of 3, or approximately a distance of 173.2 feet apart. Alright, let's take a look at the converse of the Pythagorean Theorem. The converse of the Pythagorean Theorem states that if a squared plus b squared equals c squared in any triangle, then that triangle, this one being ABC, is a right triangle. So if that statement holds true, then we know we do have a right triangle. So we'll use that to show whether or not we have right triangles or not. So the question would be, do we have a right triangle here in this slide? We have sides of 7, 8, and the square root of 113. The key to setting this up is to figure out which side is the largest. If the largest side has to be the hypotenuse if we have a right triangle, but we need to determine whether or not we have one. If you're not familiar with the square root of 113, you know that the square root of 100 is 10, and 10 is bigger than both 8 and 7. So therefore, this would have to be our C value to test out. So we check it. 7 squared plus 8 squared hopefully equals square root of 113 squared. We simplify then and solve. We do have 113 equaling 113, so therefore, since the statement holds true, we do have a right triangle. This will not work if we misplace the square root of 113, so we do have to figure out which one is the largest side. Applying